Hello, I'm Robert, and this is a letter that I've been sending. I've sent to about a dozen people so far, and since I'm not getting any responses, I'm decided to put a copy of the letter up publicly in my blog post to try and get more people, more interest, and more people to respond and to start thinking about it. My question is, why doesn't NASA respond to public concerns on its samples from Mars environmental impact statement? So first, before I get to the letter, I'm going to read it through. I just want to give a bit of background. So NASA, the Perseverance rover, has been collecting samples on Mars of rock and some dust and soil, and leaving them on the surface in tubes on Mars. We want to return them about sometime around 2033. We aren't talking about a huge risk here. They might be as harmless as microbes collected in terrestrial deserts, but they could also be independently evolved life, or they could have evolved capabilities on Mars through billions of years of evolution that terrestrial life doesn't have. And I think Margaret's racist analogy of a smoke detector is a good way of thinking about it. You don't panic about fires in your home, but you do install smoke detectors. And as Carl Sagan said, the likelihood that such pathogens exist is probably small, but we cannot take even a small risk with a billion lives. It's generally agreed that decisions like this can't be made for the public by scientists and engineers, so you all have a say in it. Don't feel that you can't on this decision. And so this is my email. Let's go down to it, that I've sent, and I'm now going to as a public letter. So I say, Dear NASA, former and current planetary protection officers, astrobiologists, flight engineers, anyone interested in the general public. And I explain my background, that I've been working. I did a first draft of all this, of my paper, way back in 2015, when I gave a presentation about Enceladus in Europa to a small astrobiology conference in Oxford in 2015. And I had a second presentation that I prepared but didn't present, I should say. And then for the last 2 years, I've been working specifically on a paper on planetary protection of NASA's Mars sample return mission specifically. So I'm reasonably familiar with the literature. So I was astonished when they didn't cite this recommendation. And this is the most recent Mars sample return study, European Space Foundation from 2012. And how can they not know about the most recent Mars sample return study? I'm just baffled. So this says that the release of a single unsterilized particle larger than 0.05 microns is not acceptable under any circumstance. And that's well below the biosafety 4 limits, which is what they're planning to use. And I checked the literature, and we don't have nobody knows how to do this. There aren't any filters that even try to do this. Nobody's even trying to achieve this in the literature. Maybe it can be done, but nobody's trying. And the group also said that it recommended that this gets reevaluated on a regular basis. And this recommendation was done a decade ago. And it said that given that it would take a decade from design to curation, it needs, and the evaluation needs to be done on a regular basis. It's a decade since they made that recommendation. It definitely needs to be reevaluated. NASA have not reevaluated the size limit. They haven't even looked at the 2012 size limit. Not in this environmental impact statement. Instead, it plans to use a BSL-4 facility, and that their recommendation, if you trace back the origins of their recommendation, it's based on a study in 1999. So it's more than 2 decades old science that they're using as the basis for the recommendation. So I asked them, why aren't you citing the most recent study? And I asked them way back in May 16. No response. I gave my email, as I do whenever I submit my public comment there. No response to my email. They don't mention it in the draft environmental impact statement, which they published in November. The public comment period ends on the 20th of December. After that, there's no more chance for public comment. They expect it to be completely finished on the fast NEPA process in spring to summer 2023. And the whole argument in the environmental impact statement is kind of weird. They miss out important studies like this one, very important studies, and they misrepresent their own sources, which is extraordinary. And they also contradict themselves pretty much. They're just so unlike NASA. I don't see I got through internal review. But I have to comment on what I can see there. It's not for me to speculate how it happened. And I tried emailing many people, about a dozen so far, including experts in astrobiology or planetary protection. Most haven't replied. Others reply just saying to ask NASA. And that's no use, as NASA aren't responding. And the many in the public who have raised concerns of one sort or another and responding and said in the public comments, and they have a section in the draft EIS where they say they responded to public comments. They don't mention this concern about BSL-4 facilities not being sufficient. They don't explain why they don't include the latest Mars sample return study. There's no response to major concerns raised by the public. It's really quite extraordinary. I've never seen anything like it. And their basic argument is that they claim in the draft EIS that credible evidence says that Mars has been uninhabitable for millions of years. Their very cite for that statement is about searches for locally currently habitable regions in a seemingly uninhabitable planet. How did that get through internal review? They say that if there is life on Mars, they say it can get to Jezero Crater. So why do we need to consider this if Mars is uninhabitable? And they do this by citing the 2014 MEPAC survey and not the MEPAC 2 one, 2015, which revised all the relevant MEPAC conclusions. The second study draws attention to biofilms that a microbe can use to make a home in extreme environments. It says regions that seem uninhabitable from orbit may have localized habitats, and it warns that we don't know if terrestrial life can be transported in dust storms. And also, their site, the MEPAC site from 2014, isn't even about the potential capabilities of any Martian life would have. It's about forward contamination of terrestrial life. And Martian life would have evolved to conditions on Mars and dust storms over billions of years. Then, if there's life in Jezero Crater, they say it can get here faster and better protected in meteorites. But there are sites there about rare cases in panspermia, such as Beta-Octopus, which is a very hardy organism. None of their sites say that life can get here faster and better protected in a meteorite. And what matters for planet protection, unlike panspermia, the theory that life can be transferred between planets, is life that can't get here. Metaphorically, it's the starlings that are the invasive species in the United States and Americas because they can't fly across the Atlantic, whereas the barn swallows which can fly across the Atlantic are not invasive. And then you have microbes such as Didymbo in the New Zealand, which can't even get from one, it's invasive in New Zealand, it's not native there, and it can't get even from one freshwater lake to another in New Zealand. There could easily be microbes on Mars that can get from one briny seep to another in the dust storms and can't get to Earth. And because of all this, they say there's no significant risk of environmental effects. Nothing needs to be considered about human health except to handle the samples like any other toxic chemical or infectious disease. But the NRC study from 2009, which they do cite, warns that though the risk of large-scale effects on the environment or human health is likely low, it is not demonstrably zero, and it warns against using the very meteorites argument they use. And they say that we have to return the samples to Earth for safety testing. That rules out any possibility of a pre-sterilized sample return, in other words, sterilized before it gets to Earth, which they don't even mention. And actually, the permitted biosignatures per gram of rock sample regulated for the return samples, rock samples, is so high that any tests for life are guaranteed to be false positives, detect positive biosignatures from Earth. NASA think they achieved a reduction to 0.7 nanograms per biosignature per gram for their most abundant biosignatures. So the safety testing is useless because the site they use for safety testing there says that the only way to check for safety is to check for this Martian life there, since we can't predict the effects of introducing novel life to Earth. And again, why are we doing safety testing if they already know Mars is uninhabitable, know it can't get to Jezero Crater from elsewhere in Mars, and know it can get back to Earth faster and better protected in a meteorite? That's what I mean by saying it's full of internal self-contradictions. The obvious solution is a pre-sterilized sample return, sterilized before it gets back to Earth. That would achieve virtually the same science, especially since the samples will have to be sterilized anyway before they can be distributed to geology labs because they never pass safety testing. And to put that in context, 1 nanogram is enough for 10,000 ultramicrobacteria. They weigh at about 0.1 picograms each. And as for astrobiology, with this level of contamination, it's not likely we can do much meaningful by way of astrobiology, just more studies to prove what we already know, that Mars was habitable in the past, bit more detail. Samples from Jezero crater from an area which we know used to be a river delta 3 billion years ago. So I suggested bonus samples collected in clean containers. We could add samples of dust, dirt and atmosphere to these fetch rover, and those could be pre-sterilised after collection before they get to Earth and still retain a great deal of astrobiological interest. I go into some details as to how it could be interesting. For instance, it could redetect microbes from the Gobi Desert in Japan, brought from the dust storms in the Gobi Desert. And the dust storms, even in distant parts of Mars, if there's even a small amount of life exposed to the surface, we might detect it, dead or possibly pre-adapted to survive in the dust storms in Jezero crater. And we could also return the very interesting vines that Curiosity found in Jezero crater, that in a Gale crater, and it's likely even more likely in Jezero crater, though Perseverance can't search for them, because it reaches 100% humidity there at night, which become little briny seeps at night, very very cold, -70°C, and then they get to above zero, above freezing in daytime, but then they're too salty for life. At night they've got enough water activity for life, but biofilm could retain the water through to the daytime, and so you might get enough water activity for life at 0 degrees centigrade in daytime if there's a biofilm in there. So they're very interesting for potentially even life there, and certainly for prebiotic chemistry. And we could return those and for simulating Mars environments, the suggested Mars environments, which elsewhere on Mars may be more habitable, and which would also involve those salts and similar process in Mars simulation laboratories. So we could return those unsterilized bonus samples above geostationary Earth orbit to a safe orbit by retaining all the geological samples. Just return the geological samples pre-sterilized to Earth for the geologists, and then explore them like the astronauts explore Mars telepathically from orbit, in some ideas for ways to explore Mars safely for both Earth and Mars and Earth life. Before we know what's there in the far future, astronauts could go to very interesting orbits above Mars and study the surface telepathically from orbit. And we can't rely on human quarantine. I gave many examples in my preprint. For instance, the 2 zinnia plants in the ISS, they died of a crop opportunistic fungal pathogen, Fusarium oxysporum, which was brought there, probably, in an astronaut's microbiome. And this is also a sometimes deadly pathogen for immunocompromises humans. It's actually second after Aspergillus in its harm for humans. And it's the sort of thing we could find on Mars. And it obviously had no symptoms for that young, healthy astronaut, whichever one it was. They don't know who it arrived on. And some natural analogue of Hachimoji DNA or mirror life, independently on Mars, could be harmless in astronauts' microbiome as independently evolved life with a different biochemistry, but spread and cause major problems in terrestrial biomes once they get here. Hachimoji DNA has 8 bases instead of 4, but it's dependent on chemicals only available in laboratories, so it's safe on Earth. But natural analogue on Mars mightn't. It might have 8 bases, but not and be able to live here. And then mirror life, that started off with mirror chemicals early on, and as DNA spying on the various starches, proteins and enzymes reversed, not all independently evolved, but reversed as in a mirror. And we don't know what would happen imagine if you ended up with half the microbes in your forests and your coral reefs and the seas and your soil are mirror life. Then would it still function the same way? But we can send over 7 tons in one payload to above geostationary Earth orbit already, that's over decades and centuries once it's adapted to Earth, if we did return mirror life to Earth. And we can send over 7 tons in one payload above geostationary Earth orbit already with the RNA-5 rocket, enough for hundreds of remote life detection instruments in one payload, because astrobiology instruments have been so miniaturized in the last couple of decades. And these instruments, they have automatic sample preparation, which they mention in the draft EIS. They say it has to come back to Earth for sample preparation. It doesn't, not for astrobiology. And there are many such instruments, and they're designed to do the entire process. For instance, there's an automatic gene sequencer that goes all the way from sample collection to preparation to analysis to doing actually computer analysis on Mars, because that is very data intense and requires large amounts of data. It only sends a genetic sequence back to Earth. And so I'm no lawyer, and NASA would need to ask an expert in environmental law, but on the face of it, they might actually be in some legal jeopardy with this draft EIS if it goes ahead. Because by a 7th Circuit decision in 1997, it's not permitted to define the scope of an environmental impact statement so narrowly as to exclude reasonable alternatives. And the pre-sterilised before it gets back to Earth, the pre-sterilised return certainly is a reasonable alternative. And the remedy back then was that the agency was told to cancel the project to build a reservoir because they improperly excluded the option of 2 smaller reservoirs, and not even because the 2 smaller reservoirs were better, just because it didn't assess that option. And since we can keep Earth totally safe with virtually no loss of science, why would NASA not even want to consider the pre-sterilised samples option? I just don't get it. I'm totally baffled and I have no explanation. So anyway, that's what I wanted to ask this is a draft letter to any interested experts. Do you have any idea what's going on? Why they aren't responding to me? Is there anything we can do to get answers to this in the general public? So do please free to share, well, this email, or in this case it's a blog post, this copy of this email on my blog post with anyone else, and or this video indeed. And if you know of anyone else I can contact about it, also do say. So I did a blog post about this which goes through this in detail, and a preprint which goes in even much more detail with citations and everything, and an annotated version of the draft EIS where you can skip through the sections of you can go to the annotated copy and look at the passages I highlighted that I see as of most concern and my comments on them. And then with the blog post, which is a kind of quite a technical blog post, you can skip through the sections, do the titles as mini abstracts for each section, so you can get an idea of the art blog post by just clicking through, and I've got links that just take you, just click one section to the next, so you can read the titles of the sections, click through, then browse through the graphics for some of the sections, and you get a pretty good idea of what it's all about, and drill into any section that you see as of most interest. And my academic preprint is done in a similar process. Haven't done link to next section links there, but I have done. But you can read the contents list, and you can then read through and see get a pretty good idea of the preprint just by reading the contents list. So this is that blog post. You can click through to it, and I hope we get to the bottom of this. The public surely need answers to their questions, as John Rummel once wrote, and which I quote in that blog post. Broad acceptance at both lay-end, public and scientific levels is essential to the overall success of this research effort. And if you're worried about this going through the NEPA, I mean, even if it does go through NEPA and if nobody alerts them to it, the next stage after that, at some point at the end of all the other legal process, is the presidential directive, where the president is required to look carefully at anything which could have even domestic, not even something that has allegations, but could have domestic or foreign allegations of long-term effects or large-scale effects. Then the president has to look at that. And if anyone looks at this and just checks the sites and reads my comment on the draft EIS and then checks it through, it's just going to fall apart. So I can't see it going through the presidential directive if it gets that far. So I've sent variations on this letter to 12 people so far and got no response. Just told to communicate my concerns to NASA, which I've already done. Do comment yourself here. I'll give a link to it. I'll put a link in the video description. I'll put a link to this blog post. I'll put a link to where you can go comment yourself. And you don't need to be an expert. It's responsive to the general public, and it's not restricted to the public in the USA. I'm asked to give my country of origin, which I gave as the United Kingdom and Scotland. You can give your country of origin. It doesn't need to be an ESA. It doesn't need to be a European country. If you're in another country, if you're in Indonesia, Mexico, if you're in Australia, you're in anywhere in the world, if you're in China, Japan, it doesn't matter where you are, you can go and comment here and say that you're concerned, say whatever your concerns are about the project. So I just want to answer a couple of common questions from the general public. First, yes, Martian life might be able to survive on Earth. If there is life, we've got Mars analog deserts on Earth. And we have life in those Mars analog deserts. And these are likely to be polyextremophiles. That's what we find there. Life that doesn't just survive in the cold deserts, but survives in all sorts of places. One of our best, we don't tend to find much by way of specialized cold life. We have some psychrophiles that like it very cold, but we have lots of extremophiles that can survive almost anywhere. An example is Cucurbidiopsis, which is a blue-green algae, so food-centric life, and it's just extraordinarily versatile. It's one of our top candidates for life that could survive on Mars. I should perhaps mention there, can reconstitute its DNA even if it's chopped into lots of little bits by ionizing radiation. And even though it's presumably not been evolved to do that, it's just got so many other protection mechanisms, probably for UV and other things. It might have got the protection against UV from being transported very high in the upper atmosphere. It's evolved over a long period of time, and it's got so many different pathways it can use. Even although it's a blue-green algae, it normally survives in photosynthesis. It's got large numbers of metabolic pathways, and some of those it can use just chemical methods, and it's been found in complete darkness over 100 meters below the seabed. So that's an example of a life form from Earth that could survive on Mars. Life that can survive from Earth on Mars, then that means this life that's on Mars could survive on Earth if it has the same capabilities. And yes, though, and indeed there's one paper I found that speculated whether Cucurbidiopsis could have come from Mars because of its resistance to ionizing radiation. That's just speculation. It's not impossible, though, we find something like that. And life on Mars could be completely harmless. I mean, it could be like Cucurbidiopsis, which, as I said, may possibly have come to Earth from Mars. But then, if Cucurbidiopsis was what caused the Great Oxygenation event about 500 million years ago, then it was good for us, but it completely transformed Earth's biosphere. So we don't know that present-day life on Mars is harmless to us. It could have developed capabilities on Earth that on Mars that Earth life doesn't have, such as resistance to UV or ionizing radiation. It's very likely to be able to flourish at much colder, lower temperatures than Earth life. And so that's my own idea. It could flourish in freezers, for instance. If you have a mold, that means your freezers have to be much colder. It could produce accidental toxins, similar to, because no Earth life can survive below minus 20 degrees centigrade, which is why freezers are at minus 20 degrees. They can survive, but they can't reproduce. But if there was life on Mars, it might be able to survive minus 30 degrees centigrade, say. So then all the freezers have to be recalibrated to minus 30. It could produce accidental toxins similar to Ergot's disease, botulism or tetanus. It could be, those are microbes that can that spread on crops and in our environment, just in our soil, and they just produce toxins. And I should mention here, I've forgotten to say there, and so they're not designed to harm humans. They just accidentally produce toxins that harm us. And then a real example there, which I think I'll put in there, is the Great Lakes. They sometimes get covered in algal blooms, which kill cows, and they kill dogs that eat the algae. So if you see algae on the Great Lakes, make sure your dog doesn't eat it, because it can cause their liver toxins that it produces, and it's not evolved in order to harm the livers of animals. It's evolved to protect itself against other microbial threats, but it just accidentally harms animals. So there could be something from Mars that just accidentally harms life on Earth through toxins. Or it could be an independently evolved life with a different biochemistry. Ecological systems mightn't work the same way, as I've said, with mirror life, Hashimoto DNA, and that alternative life. For instance, there's mirror life. There's some mirror life that produces an anesthetic, for instance. A mirror, takes a mirror amino acid. I'll double check that hasn't been anesthetic. And it could also have alternative. It could have alternative versions of amino acids, which could be misincorporated in our proteins. BMAA is an example, which is an alternative version of one of the amino acids, and this causes this disease that Stephen Hawking got. Not that he necessarily got it from BMAA, but it is one of the potential causes of that disease. And so we could have neurotoxins from life on Mars could potentially, there's a huge vocabulary of potential amino acids it could use, and it could easily contain amino acids that are not terrestrial amino acids but happen to resemble terrestrial amino acids. Then when our Earth life incorporates those amino acids, it messes us up, and we get new effects on the way our brains work as a result of the proteins folding in a different way because they take up the wrong amino acid. So there are lots of ways that independently evolved life, we don't know that if we have half the life on Earth was independently evolved life. Now I think if that happens, it would likely be to spread very slowly, because we expect life on Mars to have a doubling time of months to years, because it's so cold there, and cold life on Earth is very slow doubling time. So it would take a while to adapt on Earth, but as it warms up, and cold life from Earth does adapt on Earth when it warms up, and it's even life that, and so we could expect Martian life to, as it warms up and as it gradually doubles and does spread on Earth, it would develop the ability to spread on Earth. It would gradually evolve, it would spread around, microbes evolve very quickly, and over time, over decades and then centuries, it would spread through all our biospheres and alternative biology. And I don't think that humans would go extinct in that situation. We would develop habitats. We've got these habitats that could work even in space, for space colonies, and we could grow all our own crops in habitats, and we could cover large areas of the tropical rainforests, and we could cover the coral reefs, and we could probably preserve nearly all species, or future technology, all our species, with these various habitats. So I don't think we'd go extinct. Just let me give it a nice. I don't think we'd go extinct if we return life from Mars. That's not the concern. But I think that we could severely diminish the terrestrial biosphere, which would be an impact on future generations of humans for all time. And eventually it would be a much richer biosphere if half of it was mirror life, half of it was a biochemistry that uses different amino acids, and we would be enriching the terrestrial biosphere by returning life from Mars. But it would take a long time for life to evolve, and it might take millions of years before higher life, lower life, microbes would evolve quite quickly, but higher life might take quite a long time to adjust to this new situation of a new biochemistry on Earth. And so you get people who are saying, who talk about this almost like it's a formality, that we expect life on Mars to be harmless, but we have to go through all this just in case it isn't. We do not know in advance that life on Mars is harmless. It may be a low probability, but we don't know this. And so space colonization enthusiasts, in my view, should care just as much as everyone else about finding out what is on Mars, and is it safe or is it not safe for astronauts or for Earth. And space colonization enthusiasts could be involved in, colonizers could be involved in studying mirror life on Mars from orbit. So don't feel that this shatters your plans of space colonization. You could be an essential part of that, living on Mars's moon, Phobos and Deimos, and studying it via telerobotics on the surface, finding out extraordinary things about the biology of Mars. And we could have, I think the moon is far better for the first space settlements, first of all like Antarctica, with tourists and scientists there. And then gradually maybe we find this Hoyt's orbital tether system, which could greatly reduce the cost of returning rocks and returning the useful resources on the moon. It's very expensive to return at present. It's probably not worth doing, but if we have a very low-cost way of doing it, the titanium on the moon may be useful, the water at the lunar poles may be useful. It could be a very good starting point. The vacuum on the moon would be very useful for making making electronics and chips and things. It could be like the industrial center of Earth up on the moon. And then that could start space, it could be a very good place for constructing space ships that don't need to go through Earth's atmosphere, which will then take off and go throughout the solar system. And then the places that are much more interesting, I think personally, that Jupiter's moon Callisto is of great interest for human colonization. Outside Jupiter's radiation belt and inside Jupiter's protection from solar storms, and it's not going to contaminate Europa in the forward direction. It's covered with ice and rocks. The humans could live in underground habitats, melting the ice. It's got just about everything humans need. And then Titan is another around Saturn. Once we've got very fast transport throughout the solar system, Jupiter isn't that far away for fast transport once we've got faster rockets. And then Saturn isn't that fast with a boost past Jupiter. It is feasible later this century or early next that we're actually living on Titan. That would depend on whether there's any life that can actually live in. If it's got water volcanoes, it doesn't seem to have them. If so, it's very unlikely that terrestrial life could survive in extremely cold conditions on Titan, and it's far easier to protect against cold than against vacuum. If you an insulated diving suit would be all that you would need, because the atmospheric pressure of Titan is so high that you would just need to walk out with basically an aqualung and an insulated diving suit. You could walk around on the surface of Titan. And the ways of generating electricity from its winds, and so I'm very keen on Titan myself for colonization for the future, so long as it's safe for life, which it seems it very probably is. So that's something that you might be interested in looking into if you're a space colonization enthusiast. I myself am a space colonization enthusiast. I think humans have a place in the solar system. We need to explore responsibly. We need to do it in a way that protects both Earth and the planets. And if we do that, we can bring the entire Earth along with us. And I don't think we need to escape Earth, but I think we can go into space to protect Earth from asteroids, to find out amazing new discoveries, to explore and be as adventurous, and be in the very far future, billions of years from now, I think we are going to be living in space, or we might move Earth out away from the Sun so as to protect it as the Sun gradually expands. Or we might protect Earth using space methods, such as space shades or mirrors. I think space is a very important future for Earth. I don't think we need to escape Earth. I think that we can protect Earth, and we can protect Earth from asteroids as well. There's no need to go, there's no point in going into space to try and run away from asteroids. And I've got lots of things about that. But I go into that in separate videos. We already know all the very big asteroids that could hit Earth, and they're not going to hit Earth. The near-Earth object asteroids. We don't risk that in the near future, and in the far future we will be far better equipped than the dinosaurs. We can just deflect it. So I think that's our role in space. And so I'm very keen on space colonization, so please don't think that I'm arguing against space colonization with this letter. And so I'm going to put some other links here at the end. Do share this video, do share this letter. Please let's get to the bottom of this and find out what's going on, and get this back on track. And why do something that has a low risk of harming Earth when we can keep Earth of harming Earth's biosphere even very, very low, even just like a smoke detector level of risk for a house fire, even if it's just that low, which I think it probably is, especially with this first mission. It's also precedent for missions from China or from India or from Russia if it goes back to doing space missions to Mars, or other countries like the UAE or Japan. And NASA is so respected that if NASA uses BSL-4s, these will too, and eventually one of them is going to return any life that there is on Mars. And if we're just using a BSL-4, then that's not a good example, whereas pre-sterilizing will keep Earth 100% safe. And it's an excellent example for other countries. So that's my view. I want this looked at. Just saying, why isn't NASA looking at this? Why aren't they even citing the ESA study? And if you know the answer, please forward this video and forward this letter to anyone interested. Thanks.